Section 5-6, the fundamental theorem of algebra. Today, students will be able to use the fundamental theorem of algebra to solve polynomial equations with complex solutions. The fundamental theorem of algebra says that if a polynomial of degree n is greater than or equal to 1, then it has exactly n roots, including multiple and complex roots. All what that means is based on the highest exponent of the given polynomial, that will be the number of solutions that you will have. Some of them could be complex solutions or multiple solutions. So today's problem isn't going to be much different than the stuff we've done in the past. Now we're just going to add the quadratic formula to help us find possibly any imaginary zeros. So we're given 2x to the fourth minus 3x to the third minus x minus 6. And we need to list our p's and our q's and try our synthetic division just like before. So p are numbers that multiply to 6, so plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. I just write them in that order so I don't miss any. I know 1 times 6 is 6 and 2 times 3 is 6. If you wanted to write it from lowest number to the highest number, it would be the same thing. Okay, so then q is the number in the front, so q is 2, so numbers that multiply to 2 are just plus or minus 1 and plus or minus 2. Now we need to make our list of p divided by q. So 1 divided by 1 is 1, 6 divided by 1 is 6, 2 divided by 1 is 2, 3 divided by 1 is 3. Okay, then go back to the front and change your q value. 1 divided by 2 is 1/2. 6 divided by 2 is 3, which we already have. 2 divided by 2 is 1, which we also already have. And then 3 divided by 2 gives me 3/2. Okay, and now we're going to do synthetic division and try to get 0 as our remainder. So I'm going to start with positive 1. So there's a 2 in front of my x to the fourth, negative 3 in front of my x to the third. There's no x squared term, so I need a placeholder, a negative 1 in front of my x, and a negative 6 at the end. Okay, so bring down the 2. 1 times 2 is 2. Negative 3 plus 2 gives me negative 1. 1 times negative 1 gives me negative 1. 0 plus negative 1 gives me negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 gives me negative 2. 1 times negative 2 is negative 2, and that is not a remainder of 0. So I'm going to redo the whole thing again, and I'm going to try negative 1 this time. So negative 1, and then 2, negative 3, 0, negative 1, negative 6. Okay, bring down the 2. Negative 1 times 2 gives me negative 2. Negative 3 minus 2 gives me negative 5. Negative 1 times negative 5 gives me positive 5. And I get 5. Negative 1 times 5 gives me negative 5, which gives me negative 6. Negative 1 times negative 6 gives me positive 6, and I get a remainder of 0. Okay? So one of my roots is negative 1, and that's going to leave me with now 2x to the third because it's 1 less, minus 5x to the second plus 5x and then minus 6, okay? And then you would try to factor that, but if you draw the line down the middle of it, it's not going to be able to factor by grouping, so that means we have to do synthetic division again. And we're going to try another one of our numbers, and remember, negative 1 could work another time, or it could be another number. Alright, so you might want to start by trying negative 1 again to see if it's a multiple root. So 2, negative 5, 5, and negative 6. Bring down the 2. Negative 2, negative 7, positive 7. I don't think that's getting me anywhere close to positive 6 to make it cancel out. Okay, so maybe try 6 now from the original p divided by q. So 2, negative 5, 5, negative 6. Okay, bring down the 2. And 6 times 2 gives me 12. 12 minus 5 gives me 7. 6 times 7 gives me 42, and again, I don't think that's going to get me anywhere close to the positive 6 to make it cancel out. So maybe try negative 6 now. 2, negative 5, 5, negative 6. Bring down the 2. That gives me negative 12. And that gives me negative 17. Negative 6 times negative 17, I don't think that's going to get me anywhere. That's 102. Okay, so that's not going to get me to 0. All right, so let's try 2 now. So 2, negative 5, 5, negative 6. It might have been smarter for me to go with my smaller number next instead of trying 6, but I was just going in order. So bring down the 2. 2 times 2 gives me 4. Negative 1, that gives me negative 2. That gives me 3. And that gives me positive 6. So that one works. So now I have 2x to the second, because it's 1 less than x to the third, minus x plus 3. Okay, and since it's squared, I would try to factor it. So is there numbers that multiply to positive 6 that add to negative 1? The only way that could work would be negative 3 and positive 2, but there's no way that's going to multiply to positive 6, so I need to use my quadratic formula. So negative b, so that's going to give me positive 1, plus or minus b squared minus 4 times a times c, all divided by 2 times a. Okay, so now we're going to continue simplifying. Negative 1 squared minus 4 times 2 times 3 simplifies to negative 23, all divided by 4. Negative 23 is a prime number, so the only thing we can do is bring out the I out in front. And now I just need to write all of my answers. So x equals 1/4 plus or minus I root 23 over 4. There's 2 of my answers. Okay. Another one of my answers is the 2 from the synthetic division that worked just earlier, and then the negative 1 that worked on the other page as well. So you should have 4 answers since we started with x to the 4th. So this gives me 2 because of the plus or minus, so 2, 3, 4, and I am all done with this problem. All of these are my answers.